Hello students, how are you all? Welcome back to Akshar IT Foundation classes. I am your chemistry faculty S. Mohan, right? So, today students we are going to discuss about the same chapter, that is chemical equilibrium. In the last class, we started chemical equilibrium, right? And in that first synopsis we completed, and today we are going to do with second, right? So the first synopsis, the second synopsis is a continuation for the first synopsis, right? Now, what did you learn in the first synopsis? Did you remember? Chemical reactions, right? And in that we discussed about the rate of reaction. Then we also discussed the irreversible and reversible reactions. And then we also discussed about the equilibrium, right? So this all we discussed in the first synopsis. Now the continuation of the first synopsis is the second one. Clear? Chalo. So same chapter, chemical equilibrium. Let's move. So in the last class we discussed about the chemical equilibrium. Did you remember chemical equilibrium? Chemical equilibrium means what? When the rate of forward reaction becomes equal to the rate of backward reaction is called the chemical equilibrium. This I explained you yesterday. Okay. So once again see here, for example, okay, let's say for example, we are taking a reactants like A and B, right? So these are the reactants and reaction is not yet started. When the reaction is not yet started, then there will be no products, right? So now the concentration of the reactants is full, but the reactant concentration is nil, right? Because the products is not there. The product concentration of products is nil, right? Now when the reaction starts, okay, then what happens? This is converting into the product. Let you take C and D, okay? Let is forming the two products like a C and a D, right? So now here as the reaction starts, the concentration of AB will be decreases because A and B are reacting to form the C and D product. So reactants are converting into the products. So the concentration of the reactants will be gradually decreases. But at the same time what happens? The concentration of the products are increasing. Then after a particular amount of time, as this is a reversible reaction, again these products will be converted into the reactants. Again the products starts converting into the reactants. So reactants are converting into the products and products are converting into the reactants. Okay. So the rate of forward reaction here becomes equal to the rate of backward reaction. Yes, did I explain you yesterday one fountain example I have given, right? For example, if you take the fountain, okay, fountain. So here the fountain will be arranged in such a way. For example, see this is a fountain, something imagine, and here one, okay, one pipe is kept here. Now from this, here this consists of water, okay. So this all consists of water. Now this is the water. Now in there one motor is fixed, okay, one pump is fixed, electric motor, and so due to that what happens? This water from the, okay, this one come through the pipe, okay, pump, and it forms a fountain. What it forms here? It forms a fountain, and water, okay, they are moving through the pipe, again they are falling in the fountain only, right? So now what happens? The same water is moving like this, okay. So the fountain is complete, always it's giving the water upwards, and the same water is falling down. Whenever you see in the fountain, the amount of water will be remains the same, okay. Otherwise you can do like this also. For example, you see here we have taken one tank. Let imagine that we have taken one tank, okay, and there is a small hole to the tank. You imagine that there is a small hole to the tank. Now here we kept okay, this tank under one tap. This is a tap. So from here the tap water is running into the tank, okay. But as there is a hole is there, Now what happens? Here the water is flowing away. The water is flowing away. So imagine that how much water is falling or running from the tap, the same water is going out through this hole. Now as long as you see what happens, the level of water in the tank remains the same. Clear? Yes or no? So how much water is running into the tank? The same amount of water is leaving the tank through that hole. Now as long as you see the amount of water in the tank remains the same, this level will not be changed. Yes or no? So here water is coming into the tank and water is going away from the tank, both are equal. So here also, here AB are reacting to form the product called C and D. But as it is a reversible reaction, C and D are reacting each other, again forming the A and B. So A and B forming the product, that is called forward reaction, and C and D are forming the A and B, that is the backward. So here both the reactions are taking place. What is the rate? Rate of forward reaction is equal to rate of backward reaction. So this stage is called equilibrium. What is called equilibrium? This already we discussed in the last class, right? Yes. So now we see what are the characteristics of the equilibrium. So simple, students. So already these all points have discussed, but only thing is that they are kept in like one format. Okay, in neat sentence wise. Okay. Now let us see now. When a chemical equilibrium is established, means what? When a forward reaction becomes equal to the backward reaction. When the chemical equilibrium is established in a closed vessel. This also I told you that generally the equilibrium means reversible reactions to attain the equilibrium, that should be done in the closed vessel only. If you do in the open vessel, what happens? Some of the reactants, some of the products what they form, they get escaped from the vessel. So now no reversible reaction takes place, right? Now, so in a closed vessel at a constant temperature, concentrations and various speeds of the reaction, mixture becomes a constant. So here how much amount of A, how much amount of B, means how much amount of reactants mixture is there, and how much amount of reactants are coming from the product, and form products again forming the reactants. So the concentration mixture of reactants and products remains same. Okay, because the rate of forward reaction is equal to rate of backward reaction. Next, the reaction mixture at equilibrium is called equilibrium mixture. Now when this reaction occurs equilibrium, attains equilibrium, at that time, at the state of equilibrium, whatever the mixtures are there, those mixtures are called equilibrium mixtures. Third one, the concentration of the equilibrium are called equilibrium concentrations. Already I said you that concentration can be expressed in terms in the square brackets, right? So concentration of A, for example. So this is concentration of A. Concentration of B. So this is called a concentration of B. Generally concentrations are symbolized or represented in the square brackets. Okay. So here the concentration at equilibrium are called equilibrium concentrations and represented by square bracket and their units are moles per liter. Concentration, how can you explain? Moles per liter, right? This already we discussed in the solution chapter. Remember once, solution chapter we discussed about the concentrations, right? Now, the state of equilibrium of a reversible reaction is opposite from either side of reactants or products. So, if you are taking the reactants, that form the products. If you are taking products as a reactants, then it gives a reactants. Okay. So, here equilibrium can take place anyhow from the forward reaction or backward reaction. Means for example, if you are taking A plus B, here two reactants you are taking, so you are getting the C plus D or the products. Okay. But it is a reversible reaction. For example, if you take C and D only, okay, C plus D, now what it forms? It forms A plus B, okay. So, again after some time, the rate of forward reaction becomes rate of backward reaction. So, equilibrium may take from either any direction, from the forward direction or backward direction, okay. So, this is about this one. And here example is hydrogen, when react with iodine, it forms a hydrogen iodide in the closed vessel. If you do, then that's a reversible, okay, equilibrium reaction takes place, right? And here these are the diagrams. Instead, I explained the diagram also. So when you plot a graph for the time and concentration, initially see here these are the reactants, these are the products, right? So see in these are the reactants, these are the reactants. So initially reactants are very high. So now as the time is going on, concentration of the reactants is decreasing, see coming down, decreasing. After some time they become sort of constant, see the straight line, so constant. Now if you see the product, what's the product here? Hydrogen iodide. In the starting of reaction there is no product, so this is starting from 0. As the reaction is going on, that is forming the product. So what happens now? The products will be in concentration of the product will be increases, and after some time what happens? Again these products are converting into the reactants, so that becomes to equilibrium. So now it becomes a straight, like this also we can write here, or like this also we can write, okay, and here we can write. So initially the reactants, okay, concentration is decreasing, product concentration increasing. After some time both remains a constant with the time. So these are the characteristics of chemical equilibrium. Clear? Chalo, once see this one, if you want to pause it, pause and read this one, and already it is there in your material, okay. So you can read from the material also. There are the characteristics of chemical equilibrium. Is this clear? Chalo. Now let's go to the next topic. So now here, what are the conditions, okay, for the equilibrium? What are the conditions for the equilibrium? So condition you see students here, already I said that equilibrium will be taking place only in the closed vessel, when the vessel is closed. When the vessel is closed, okay. Yesterday I told you that. For example, if you take the calcium carbonate and you heat in an open beaker, then decompose into calcium oxide and carbon dioxide. But as a carbon dioxide is a gas, then what happens? Carbon dioxide escapes and only calcium oxide is left. Does it take the reversible reaction? No, now it will reversible reaction not takes, because whatever the carbon dioxide is forming, that is escaping out of the vessel, so we cannot. So here the condition is that should be, okay, equilibrium should be, it takes place only in the, okay, closed vessel. And second one is what? Here the catalyst. This also yesterday I told you that. Catalyst means what? Which promotes the rate of reaction. Yesterday I told you that one example, like who are the catalysts for the students? Tutors. Okay, tutors are the like catalyst. They said like acts as like a catalyst. Okay, so teachers will explain, okay, in a school in a very nice way. Okay, because they are the professionals. Teachers are professionals. You know professionals. So your teachers are professional students. Remember that your teacher have a, okay, they are excellent in teaching, excellent in knowledge, and well experienced. Okay, but still some students cannot okay, recognize the teachers, and they could not concentrate on their studies, and they score the less marks. Then what the parents do? The parents appoint one tutor, right? So this tutor, what he will do? He will, okay, make the students to read. What is making to read? Whatever the concept explained by the teacher, the same thing he is making to read the students and making him to score the good marks. So here, like tutor is improving the marks of the students. Okay, not in all cases, in few cases, right? So here like this is this example I have given. So here also, here the catalyst cannot alter the equilibrium. Means what? The equilibrium means it cannot alter, means forward to backward or backward to forward, but it only helps to get the equilibrium in a faster way. Okay, so say the catalyst cannot change the equilibrium. Okay, only it speeds up the forward reaction or backward reaction to same extent. Okay, that's all. And one more important point is that is the Gibbs energy is minimum, or we can say that the Gibbs energy is 0. Okay, at the equilibrium. What is Gibbs energy? That we'll discuss in the next classes. Okay, so that is about this one. Clear? Okay, so these are the conditions, students. Once you go through the conditions, okay, then come to the disturbance in the equilibrium. Disturbance in the equilibrium is what's here. To maintain the equilibrium, certain conditions should be maintained constant. Means what? Temperature, concentration, pressure, and this should be maintained constant. Okay, means what? You should not increase the temperature, you should not decrease the temperature, you should not increase the pressure, you should not decrease the pressure, you should not increase the concentration of the reactants, or you should not decrease the concentration. Okay, in such cases, when all the maintained constant, then equilibrium also will be constant. But if you disturb anything, means if you are heating additionally, if you are providing more temperature, or if you are exerting some extra pressure, or so you are increasing the some concentration, then what happens? Equilibrium get disturbed. Okay, so here the system in equilibrium state will continue. Equilibrium state will continue to be in equilibrium as long as the external conditions are not disturbed. Means what? It should not disturb. It should not change the temperature. It should not change the pressure. It should not change the concentration. As long as the external conditions, if you don't change, the equilibrium will be remains constant. If you change, then what happens? So that is equilibrium, the macroscopic properties such as concentration, temperature, pressure, and this. Okay, so this is about the disturbance. So you have to maintain the constant temperature, constant pressure, and a constant concentration, so that the reaction will be taking place. Means the equilibrium will be continued. If you change the external, means these properties, then what happens? The equilibrium may be get disturbed. Is this clear? So that is about the conditions and disturbance. Any doubt? Chalo, pause the video once and read. Otherwise, in your material it is there, so you can read from the material. Okay, students. Chalo. Let's go to the next one. Chalo. Now we are coming to the very important topic, that is called as a active mass. So it's looking like new word, active mass, no? So students, it's not at all a new word. Okay, active mass is nothing but a concentration. Active mass is nothing but a concentration. So the concentration of the reactants is expressing with the active mass. Only the word, the name is changed, but meaning is same. So active mass is nothing but a concentration. Okay, so see now, the term active mass means concentration of the reactants. What is that? Concentration of the reactants. And concentration of the reactants is explained in terms of what? Moles per liter. Concentration is explained in terms of what? Moles per liter. So it's expressed in moles per liter. That's called molar concentration. Molar concentration. But for few instances, sometimes the gas also may be used. When the gas is used, then that may be expressed in terms of pressure also. Okay, so pressure also, for example, say the pressure of reacting gases is atmosphere. So like this we can express. Okay, and concentration normally it is kept in the indicating by using the square bracket. What it is? A square bracket. So say now, so active mass usually expressed in enclosing the symbol called a square bracket. Okay, in the previous slide also I showed you, that is somewhere this one. Okay, so square brackets are used to express the concentration, right? So concentration is what? Number moles per liter. Okay, moles per liter. So the same thing you can write. So see, active mass is equal to number of moles of the substance by volume in liter. Number of moles. See, the molarity, did you remember the molarity? Molarity in the solution I explained you. Molarity is equal to number of moles by volume of solution. But what is number of moles? Number of moles is nothing but a weight of the solute by gram molecular weight and into 1 by V in liters. Or we can write weight by gram molecular weight into 1000 by volume in milliliters. This I give for the molarity, right? So molarity is what? It's what do you say? It's a term to express the concentration of the solution. Here also we are explaining about the concentration. Okay, but instead of using the concentration word, we are using the active mass. So active mass is nothing but a concentration, students, remember that. Okay, so see now, number of moles of substances by volume. So see here, number of moles is what? Weight by molecular weight. See, weight by molecular weight into 1 by V in liters. Okay, weight by molecular weight into V liters, or 1000 by V milliliters. This already we discussed, students, in the in the solution chapter. Okay, what we discussed in the solution chapter, the same thing we are discussing, but just instead of molarity, we are using the word called active mass. What we are using? Active mass. Clear? Chalo. Here, now active mass, based on this, we have one law which is called the law of mass action. What is that? Law of mass action. Very simple. Law of mass action. Okay. So first I'll explain you the law of mass action. Then you yourself you can define it. Okay. If once I'll explain, then yourself you can define the law. Okay. So if you read the law, you don't understand. But if I explain, if you can understand, then you can define the law very easily. Is this clear? Chalo. Now what is the law of mass action? It is nothing but, students, for example, you say there are some reactants, like we have taken the previous slide, A plus B. So A is a reactant and B is also reactant. Two reactants, so there A and B, right? So now, for example, during the chemical in the previous chapters in organic chemistry, like you have did some chemical reactions, like for example, like this. Okay, 2Mg plus O2 gives rise to 2MgO, like this, no? Okay, this reactions we have discussed. Okay, so here instead of A, here just A is there, so here some number is there, so I am taking that X. Okay, X moles of A reacting with the Y moles of B to gives rise to what we can write here, M moles of C plus N moles of D. Is this clear? This you understood? Try to understand here. Just here, magnesium burns in oxygen to form magnesium oxide. This you know. Okay. But after balancing the equation, what you will get? 2Mg plus O2 gives rise to 2MgO. This also you know. So here 2 represents what? A number of moles. So 2 moles of magnesium react with, there is no number, 1 mole of oxygen to form 2 moles of magnesium oxide. Correct? So here this 2 moles represents what? A concentration. This 2 moles represents what? A concentration. Right? So now instead of writing the 2Mg oxygen something like this, I am taking some general equation. Here 2 reactants, that is A and B. So X moles of A reacting with the Y moles of B, both are reactants. Okay, X moles of A reacting with the Y moles of B to form the products C and D. So how many C is formed? M moles of C and N moles of D. These are the products. Right. Now, what the law of mass action states that when these both reactant, it gives a product. Right. Now, what is the rate of forward reaction or rate of reaction? Rate of reaction already discussed. Okay. So, how fast this reaction is taking place, right? So, the rate of reaction. So, rate of reaction is directly proportional to the product of active masses. Product of active masses means what? The rate is represented with R, is directly proportional to. So, here you see active masses means concentration of, here what are the reactants? A and B. So, put A and B in the square brackets like this. Okay. If here coefficients are there, they can write X and Y. So, that's all. So, here we are multiplying. What we are multiplying? Concentration of A and B. A and B are what? A and B are the reactants. Okay. So, when you are multiplying, that in mathematics, what is called a product. What is called a product. So, what is our rate of reaction? So, rate of reaction is directly proportional to the product of active masses of reactants. So, here at the constant temperature, the rate of reaction means R is directly proportional to, see this symbol represents directly proportional to the product. Product means what? Multiplication of active masses. Active mass is nothing but a concentrations. So, this is called law of mass action. What is called? Law of mass action. Clear to you? So, the rate of reaction is directly proportional to the product. Product means what? Multiplication. product of active masses. Okay, so this is right. So now, so this is the same thing. Okay, now let's go to the next. Here let us see now. Here you see, students, now here, yeah, this equation is given here. So see, this equation is given. Okay, so here x moles of A reacting with y moles of B to form or to give the products m moles of C and n moles of D. Right, now we apply two reactions for this. See, this represents the forward reaction, this represents the backward reaction. Now in the previous slide, rate of law of mass action, what it says, rate of reaction is directly proportional to this one. So this we write forward reaction. Then what happens forward reaction? Rate of forward reaction is directly proportional to your reactants are what? A and B. So concentration of A, so A to the power of X into B concentration of B. Okay, this is the rate of forward reaction according to law of mass action. Okay, now rate of backward reaction, what happens? See now, rate of backward reaction, what happens? Like this we are going now. Now like this we are going. So this becomes a reactant, this becomes a product. Now see, rate of backward reaction RB is directly proportional to concentration of C and concentration of D. Product of concentration of C and concentration. Product means what? Multiplication. Concentration can be represented in a square bracket. So C to the power of M into D to the power of N. So this is the rate of forward reaction. This is the rate of backward reaction. Clear? Now see, the same thing is given here. See, according to law of mass action, the rate of forward reaction, that is RF, is given by RF is proportional to A to the power of X and A to the power of B to the power of Y. Right? Now see here, same. This is a now. So when you remove this proportionality sign, then what will get? RF is equal to, we write KF. What we write here? KF. Okay, and this remains same, A, X and B, Y. Same here also. Here also what we do? Okay, when you remove this proportionality sign, you get one constant. So RB is equal to rate of backward reaction is equal to, in this place you can get one constant, that is KB. KB and a concentration of C into concentration of D. Clear? Any doubt? Now see, students, here very, very important thing I am going to explain you now. This once again I am writing here, this one and this one. So see here, rate of forward reaction is equal to KF. Okay, and product of concentration of A into product of concentration of B. Sorry, here should be B. Okay, now this I am writing here, rate of backward reaction is equal to KB and concentration of C and D. Okay, right. Now at equilibrium, what happens? At equilibrium, what happens? Rate of forward reaction is equal to rate of backward reaction. Yes, rate of forward reaction is equal to rate of backward reaction. Correct. So now what you do? Rate of forward reaction is RF. Rate of backward reaction is RB. These both are. This is equal to this one. So what we can write now? So this is equal to this one. So see here, RF is equal to RB. But RF is what? RF is this one. So write KF into A, concentration of A and concentration of B is equal to, RF is equal to this one. RB now. RB is equal to this one. So KB, concentration of C into concentration of D. Clear? Now what you do? This KB bring this side. This side, and this you carry this side. So when you bring this side, it becomes denominator. Yes. So now see what it becomes now. KF by KB is equal to KF by KB. This is going that side. So then it becomes what? Concentration of C into concentration of D. Divided by this going there. So this is concentration of A into concentration of B. correct? So now the ratio of this is divide is it. So division is means what? A ratio. The ratio of okay, the ratio of Kf by Kb is called equilibrium constant. What is called equilibrium constant? What is called equilibrium constant? So equilibrium constant is what? See now definition. By using this you can write the definition. This equation. See now. Equilibrium constant. See here, the equilibrium constant is defined as a ratio. Ratio means what? Division. So see here, division. Okay, ratio of the product of the molar concentration of products. Okay, products means what? Products in the numerator and to that of the products of molar concentration of the reactants. Reactants in the numerator. So products C and D are what? Products in the numerator and reactants in the denominator. So this is a very important equation to solve the numericals here. Is this clear? So once go through this one, 1 minute, once go through this one. So once pause the video and then see that. Okay. Two reactants are there, A and B. So X moles of A reacting with Y moles of B to form the products M moles of C and N moles of D. And a rate of forward reaction according to law of mass action, rate of forward reaction is directly proportional to the product, okay, of the concentrations of reactants, and backward reaction is also directly proportional to the concentration of the products. So now this we can write in this way, this we can write in this way. Now on finding the ratio at equilibrium, then we'll get this one. This is called as a equilibrium constant, and equilibrium constant definition is here. The equilibrium constant will be defined as a ratio between the product of the concentration of the products, okay, to their concentration of the reactants. Clear? So this is about this one. So students, here this reaction is used okay, for the when the reaction is at equilibrium. Okay. Now, so see the same reaction here what I said here, K equilibrium is equal to Kf by Kc, Kf by Kb, C to the power of m, D to the power of m, this one. So the same thing here it is given. Okay, see Kc, okay, equilibrium C to the power of m into C D to the power of n by A to the power of x by A to the power of y. So meaning is what here Kc, how can we define? It is nothing but a ratio of product of molar concentration of products, C and D are the products, by product of the molar concentration of reactants. That's all. Clear? So this is about the equilibrium constant. Okay. So equilibrium constant. So if the reactions involve the gases, okay, if the reaction involve the gases, I said you that if the gases are involved, we have to express in terms of the pressure. Now, then what happens? See here. Here we have to take it concentration for the same reaction. If the gases are there, then you have to explain in terms of the pressure. So same reaction we can write like this. Okay, Kp is equal to Cz. So instead of C, what we write? Partial pressure of C. What we write? Just in the place of C, nothing is changing. Partial pressure of C. C, Pc I am writing, and here M is it. M I am writing as it is. Here D is it. So what I should write? Partial pressure of D to the power of n by here A to the power of x. So what I write? Partial pressure of A to the power of x, and what I write here? B. So I write Pb, partial pressure B to the power of y. Now you check this equation then in the next slide. See, Pc to the power of m by Pd to the power of n. So see that. Where is it? Yeah. So here you can see it. Right here. So Kp is equal to Pc to the power of m into Pd to the power of n, and P, okay, partial pressure of A to the power of x into partial pressure of B to the power of y. Okay, same. So here, if the reactants or products, okay, involve the gases, then we express in terms of the partial pressure. Okay, and here the equilibrium constant is represented with the Kp. So P for pressure. Clear? So here, like concentration equilibrium constant, when the reactants and products in the reversible reactions or in the gaseous state, remember this is a very important point. Gaseous state, the partial pressure can be used instead of concentration. So instead of concentration, what you have to use? The partial pressure should be used. So same equation, but just in terms of concentration, you have to write just P. You have to write. That's all. Okay. So this is about the pressure. Okay. So that is that, student. Okay, partial pressure of the equilibrium constant. And so see here now, for example, here some are given. So see here, now these are the reactants. So this is the product. Now how can you write Kp? So Kp is equal to, see here now, Kp is equal to, first what are there? Products are there, then reactants is there, right? So product. Your product is what? Ammonia. Here NH3 should be there, 3 is not there. So here partial pressure of ammonia, NH3 divided by, now here reactants. What are the reactants here? Reactants is nitrogen. So partial pressure of nitrogen, okay, into partial pressure of hydrogen. So hydrogen. Now hydrogen. But here, how many moles of hydrogen is there? 3 moles. So write 3 here. How many moles of nitrogen is there? 1. Need not write. How many moles of ammonia is there? 2. So write 2 over. That's all. So see now, this is the answer. Clear? Now you can write for this one also PCl5, this one. So this is these are the reactants, these are the products. So first you have to write the product. So Kp is equal to PCl3. Any number is there? Nothing. So partial pressure of PCl3 into any number? No. So partial pressure of Cl2 divided by, this is a reactant. Any number? No. So partial pressure of PCl5. Okay. So that's all over. How simple? Okay. So based on this, you have a numericals also. What do you have? Numericals also. Correct? So that's about the partial pressure. Now last and final topic, this is characteristics of equilibrium constant. Okay. So we, from the first slide, what we studied, first slide, characteristics of equilibrium we studied. Okay. Characteristics of chemical equilibrium we studied. Now what we are studying now in this topic, last topic, characteristics of equilibrium constant. Okay. Characteristics of what? Equilibrium constant. Equilibrium constant we are studying now. Okay. So what are the characteristics? So difference you see. First we studied about the characteristics of chemical equilibrium. Now we are studying the characteristics of equilibrium constant. Okay. Equilibrium constant means what? Kc or Kp. Okay. Kc or Kp. Okay. So this is equilibrium constant. Okay. Kp. And this is equilibrium constant Kc in terms of concentrations, in terms of pressure. Okay. So that we are going to study now. So see here, this also already you know everything, but once again. So here, its value is a constant at a given temperature. Its value is a constant at a given temperature. When as long as the temperature remains same, so the equilibrium constant value also remains the same. Equilibrium constant is independent to the presence of catalyst. Already we discussed it's independent, means it's not dependent on the catalyst. Okay. And the Kc and Kp value depends on the way of expressing the system. Yes. So if you are expressing in terms of concentration, we write the Kc. In terms of pressure, we are writing Kp. So that depends on what way you are expressing. Okay. The equilibrium constant is reverse reaction. For reverse reaction is equal to inverse of the equilibrium constant of forward reaction. Okay. And the value of equilibrium constant is independent of the initial concentration or reactants. So initially, how much reactants you are taking, or how much products are forming, it's not depend on the initial concentration of the reactants on product, but it depends only at the stage of equilibrium. When the equilibrium, when the rate of forward reaction becomes equal to rate of forward reaction, at that time what is the concentration of the reactants and products, that only we consider. Right? And here the units already we discussed for Kc moles per liter, and for Kp that is in atmospheres. That's all. Yeah. So with this is finished. Now let's solve some questions here. Right? So here you see now, according to the law of mass action, the rate of chemical reaction is proportional to the concentration of reactants. So this is the right answer. Okay. So that's the first answer. Second one is what? See, the active mass of 64 grams of hydrogen iodide in 2 liters flask would be. This is a numerical. Okay. So see now. Here already I said that active mass formula. Active mass formula is equal to number of moles per liters. So number of moles is what? Weight by molecular weight, right? So weight by molecular weight into 1 by V. Yes or no? Okay, already seen, student, you don't get confused here. Okay. This one. Okay. So the formula, this formula I am using. Weight by molecular into V in liters. Okay. This formula I am using. So every time I can't go back, just you have to remember the formulas. So now weight is given how much? Weight is equal to 64. Okay. 64. So I'll write here. Okay. 64 divided by molecular weight of hydrogen iodide is how much? 128. Hydrogen is 1, iodine is 127. You have to remember that. That is 128. Okay. Into 1 by V. V how many liters? 2 liters. So write it 2. 64 ones are 64 twos are. So denominator 1 by 4. 1 by 4 is equal to 0.25. Is there answer? Yes. So the 0.25 is the answer. How to solve? Understood? No? Weight by molecular weight into 1 by volume in liters. So weight is given 64 grams. Molecular weight you should know. Okay. So molecular weight of hydrogen iodide is what? 128 into 1 by V. V is what? Volume. So 2 liters already is given. So writing 2. 64 ones are 64 twos are. So 1 by 4. 1 by 4 is equal to 0.25. Correct. Now, third question you see. Third and fourth both are same. In this one I'll explain you, one you can do it. A simple way. So for a system C, both same questions. For a system A plus 2B gives rise to C. The equilibrium concentrations of A, B and C are given 0.06, 0.12, 0.216 respectively. The equilibrium constant for the reaction. Same. Here you see this also same. Here two reactants A and B and giving C and D at equilibrium the constant same A, B, C, D and same. Asking to find the equilibrium constant. So which one shall I say, third or fourth? In the third, okay, I'll say the third one only. Why? Because here 2 is there. Okay, here all A, B, C, D only is there. Okay, the formula remains same. Formula already what I said. The formula C, the formula that is equilibrium constant. Okay, K C is equal to concentration of C to the power of M D to the power of N by A to the power of X and B to the power of Y. So if two reactants and two products are there, these are the reactants, these are the products. So you directly can apply this for this fourth question, this formula. Only you have to substitute these values. Okay, these are values you have to substitute. Okay, or whereas this third one what you do, same, but here you see only product, only one is there. So that's what we do. We erase this one. We don't want this one. Okay, because only the product is only one is there. Okay, so now substitute here form value, this one I am doing. So K equilibrium is equal to, C means what? A product, that is 0.216. 0.216, you need not write to the power of M or anything here. And here you write A concentration is 0.06. So 0.06 into. And you see the B is given as a 0.12, but here 2 is a C students here. Okay, 2 moles of B. So you write the power B. Okay, 0.12 to the power of square. Clear? Okay. Now you have to do this one here. So do you know how to do this one? 0.216 divided by calculation part you have to do. Okay. You should do the calculation part. Can you do? So this becomes what? 216. Because after point I am taking 3 digits away. So this becomes into 60 into here 12 whole square. 0.12 whole square means 1 2 whole square. 12 12s are 144, you know that. So this becomes 0.014, 0.0144. Okay. Now you cancel here. On cancelling, what you'll get here? Here, if you remove this one also, you can cancel with 6. Can we cancel here? Yeah, we cancel. 6 10s are 6 2s are 18, 36. 6 6 are 6 3s are 18. 6 3s are 18, 36 will get. Can I cancel 36 1s are 36 anywhere? 36 2s are 72, 72s are 144. Yes. So we'll get 0.04. Okay. Now you'll get 1.0.04. You'll get on dividing, you'll get approximately, I think, 100 by. What do you get here? So do the calculation part. I'll do the again. Calculation part I think should do. What happened? I'll go some new slide somewhere and we do the calculation part. 0.06 into 0.12 into 0.216. Where I can go? I'll go to the new slide now. Okay, here we'll do. What is the problem? The problem is, which problem that is? Second and third problem, no? So here, given what? Equation is given A, there is a gas, plus 2B gives rise to C. Okay, concentration of A is given 0.06. Concentration of B is given 0.12 and concentration of C is given 0.216, correct? Okay, so what is the formula? Formula is what? Kc is equal to concentration of C, direct I am writing 0.216 divided by concentration of A 0.06 into here B 2 moles. So power you have to take 0.12 whole square. Clear? So this becomes 0.216 by 0.06 into 12 12 is 144, 0.0144. You'll get this one, students. Okay. So here total denominator, how many zeros are there? Points after, how many digits are there? 1, 2, 3, 4, 5, 6 digits are there. Okay. So then what we can write? 2, 1, 6. So total 6 digits are there. 1, 2, 3 zeros I'll keep. And here I'll multiply this one. Others I'll write directly 6 into 144. I'll write directly like this. So now if we cancel this one, 6 3 is 18, 3 will be left 36, 3 6 6 6 so 3600 divided by 144, right? So now 36 ones are 36 fours are, so I'll get 100 by 4, correct? Oh, sorry, 3 zeros are there. Okay, 3 zeros, 1000 by 4. So 4, if I divide the 1000, I'll get to 250. Answer is there at 250. Once you check. Check the answer. 250 is there. Yeah, 250 is there. So these are right answers, students. Understood? No? Very simple. So you need to do the calculation part. Okay. So the same way you can do the fourth one. Fourth one is also very simple. See here. A plus B, the same problem once will do, so that we can understand how to do. A plus B gives rise to C plus D. A plus B gives rise to C plus D. Now A is what here? Concentration, how much is given in the of A? A is given 0.5 and B concentration how much is 0.8, and here C concentration is 0.4, and D concentration is given 1. Okay, D's concentration is given is 1.0. Correct. So now what's the formula is what? Kc. So Kc is equal to concentration of C with concentration of D by concentration of A and concentration of B. Correct. So now concentration of C is what? 0.4 into 1.0 means what? 1 divided by 0.5 into 0.8. That's all. So now 0.41 is 0.4 only. Here you will get 0.5 into 5 8s are 40. So 0.40 you will get. Okay. So 4 1s are 4 10s. So you will get 1 by 10. That's equal to 0.1. Answer is there once you check. Check whether the answer is there or not. 0.1. Yes. Okay. So like this you can do the problem. Clear? Right? Any doubt? Now then go to the next one. The knowledge of equilibrium constant helps us in predicting the extent of reaction. Yes. And predicting the direction. Yes. Whether it's a forward, this also we know. Calculation the equilibrium constant, just have calculated all these things. Yes. So all the above is the right answer. So option is, fourth option is the right answer, students. Next, what is the equilibrium constant expression for the reaction? C plus CO2 gives rise to 2CO, right? So for this, what is the answer is, okay. So here you see here this is a carbon is a solid and this is a gas, this is a gas, correct? So now for this what you do is, so here for the 2, correct only, 2CO2, so I'll write here, product, so product is what? 2CO, so CO to the concentration of 2 divided by reactants, concentration of C and a concentration of CO2. Okay, so where is that? CO2. But here I said no, the carbon is a solid, so we don't take the solid here. Solid constant becomes 1. So CO to the power of 2 by CO2. This is the right answer. So that is option is third option. Okay. Now next one. Next one is what? If the value of K is large, then the K value is larger, then the reactants is more stable. No, the products are more stable. The option is 7. Next, if K1 is an equilibrium constant for a particular equation, there is one equation, and that is K1 is there, and for K2 for some new equation which is obtained by the multiplying the first equation. Okay, multiplying the first equation. So multiplying the first equation means what? If the number of moles are there, then what we are writing? This 2 is there. So this 2 what we are writing as a power. So the answer is what? K2 is equal to, this is the right answer. Right? Next, the equilibrium constant of the reaction P2Q is K1, Q2R is means what? One reaction is giving rise to Q, the Q is giving rise to R. This equilibrium constant is K1 and this equilibrium constant is K2. So the answer is K1 into K2. This is the right answer. Okay. And according to law of conservation of calcium carbonate gives rise to calcium oxide plus carbon dioxide and rate of the forward reaction. Okay. Rate of the forward reaction is what? Here to here. Okay. Rate of the forward reaction is what? So rate of the forward reaction, rate of backward reaction. Okay. So here you see now. So what is the equation is given? CaCO3. Right. So see here CaCO3. This is solid. Gives rise to CaO. This is also solid. Plus carbon dioxide. This is a gas. This is very important. So you need to remember here. Okay. So this is a solid. This is the solid, and this is a gas. Okay. So equilibrium constant is what? Equilibrium constant is what? K equilibrium is equal to product. In the product only one gas is there, that is carbon dioxide, right? Divided by, yeah, nothing is there. Okay. So this is solid, that becomes 1. Okay. So the answer is the answer is first one is the right answer. You can write even fourth. Yeah, first one is the right answer. Okay. So in this way you can solve the problems, right? So very simple chapter. With this we completed this chapter, and also we completed our total chemistry syllabus, right? This is the last chapter, last synopsis. In the chemical equilibrium we have only two synopses, and these two synopses, with this we completed the chemistry IIT foundation for your 9th class. Okay, but this chemical equilibrium, there's lot, and this will be continued remaining part in the 10th class also. Okay, so students, bye, take care, study well.